In this video, I'll show you how to do a test for the difference between two population proportions. And the data we'll look at is for a tax preparation firm, and they have two offices, and each of the offices has taken a random sample of returns and looked for errors. And in the first sample for Office 1, they sampled 250 returns and got a sample proportion of 0.14. And the second office took a sample of 300 returns and got a sample proportion of 0.09. If we take a weighted average of those two sample proportions, we get what's called the pooled estimator of the population proportion. When we're testing the equality between two population proportions, we're testing whether they're equal to an overall proportion, and the pooled estimator of that proportion for this data set is 0.1127. If we use this formula here, then we obtain the standard error of the difference in the sample proportions, and that's based on the pooled estimator, and it comes to 0.0271. And then the test statistic is the difference in the sample proportions divided by that standard error. That comes to 1.846. And so our p-value for a two-tail test will be the sum of the tail area to the right of 1.846 plus the tail area to the left of minus 1.846. And we can calculate that using this formula, and it comes to 0.0649. Let's do the test at a significance level of 10%, so 0.1 for alpha. And then the decision criteria is the usual thing. If this p-value, 0.0649, is less than the alpha, 0.1, then we would reject the null. And it is, in this case. 0.0649 is less than 0.1. So we reject the null hypothesis, which suggests that there is a difference in the proportion of returns with errors in the two offices. The other way we could do this is with a critical value. So here's the critical value for an alpha of 0.1, two-tail test. So we put half the alpha in one tail, half in the other tail, find out what value of normal distribution would give 0.05 in the upper tail, and it's 1.645. And then the decision criteria using the critical value is this test statistic either in the upper rejection region beyond 1.645 or the lower rejection region beyond minus 1.645. It's in the upper rejection region because it's above this number, and so again we reject the null hypothesis. The other thing we could do here is we could calculate a confidence interval for the difference in the population proportions. And to do that, the standard error formula is actually a little bit different. And it's using the sample proportions, the 0.14 and the 0.09 in this formula here. So it's not quite the same value as the standard error that's used in the hypothesis test. Let's do a 90% confidence interval, so corresponding to an alpha of 0.1. Margin of error is the critical value from the normal distribution times the standard error, comes to 0.045. And then the lower bound of the confidence interval goes from the difference in the sample proportions, which is 0.05, minus 0.045, so that's 0.005, and the upper bound is the difference in the sample proportions, 0.05 plus 0.045, so 0.095. So we're 95% confident that sorry, 90% confident, we're doing a 90% confidence interval. We're 90% confident that the population proportion, the difference in the population proportions is in our interval. What would a upper tail test look like in this case? So again, everything up to here is the same. But the p-value for an upper tail test is just the tail area in the upper tail to the right of 1.846. The two-tail p-value included the tail area in the left tail, but the upper tail p-value just includes the tail area in the upper tail, so it's going to be half of the two-tail p-value, 0.0324. It's less than our alpha, so we reject the null hypothesis. We look at the critical value instead. Critical value for an upper tail test is the value of a standard normal random variable that has an upper tail area of 0.1. That comes to 1.282. Is our test statistic either above 1.282 or below minus 1.282? Sorry, we're doing an upper tail test. All I care about is the upper tail. So the decision criteria is the test statistic 1.846 in the upper tail? In other words, in the upper rejection region beyond 1.282? Yes, it is. So again, reject the null hypothesis. Let's see how Excel stat deals with all this. So we'll select our data. See parametric test, tests for two proportions. Actually, we don't select our data here. We actually have to input our results because this dialog works a little differently to the other ones. So 0.14 is the sample proportion for sample 1, 250 is the sample size, 0.09 is the sample proportion for sample 2, 300 is the sample size. The data is formatted as proportions. I'm going to do a z-test. I'm not going to do a continuity correction here. Under options, we'll do a two-tail test for a hypothesized difference of 0, significance level of 5%. And here, where we select the variance, this is where we're selecting the pooled estimator of the population proportion, and that means that the standard error that we use has this format rather than this format. So select the second one here, and if I OK that, there's our results. And let's check our numbers. 1.846 for the test statistic, matches what we got. Critical value 1.96. Oh, I did this wrong, didn't I? What did I do here? Oh, that's silly. 1.96 is what I should be getting here. Let's correct that. File not found. What are you telling me? 1 minus L7. Oh, that's even worse. Oh, that's why. It's because we're doing an alpha equal 0.1 test. So let's undo all that. There we go. Back to 1.645. This is correct. Let's run the test again, though. Use the right significance level, because we ran it using a significance level of 5%. So we can easily change that, remember, if we click on the red triangle here, bring back the dialog box, and let's go to options and change the significance level to 10%. Okay, that should be a little better. Okay, so 1.846 for the test statistic. There's our critical value now, 1.645. Our p-value, 0.065. Is that what we got? Yeah, 0.0649. It's more accurately represented up here, 0.0649. Yep, that's right. And conclusion, as the computed p-value is less than the significance level alpha equal 0.1, we should reject the null hypothesis. And here's the confidence interval, and that matches with what we got as well, the 90% confidence interval. Okay, so that's a two-sample z-test for population proportions when we have two independent samples.